Is it visible? I think just wait for this one because I think that yes, we are taking last session on this new base, and even we are going to work on the means today and tomorrow. We are going to work on this. So new base today will cover up, and K means also introduction part. Introduction part also I will give it to you, and a little quick recap also I'm going to show you. So I think yesterday those who joined, I think you have learned a lot of things. Next, what we'll learn, then K means, and then we'll go for the addition neural network session. Then we'll work on it. Let's see what topics that I have. Is it visible? The screen is visible, right? Yeah. So naive bias, what is a naive bias? Naive bias is in classifier. This is supervised classification algorithm purpose we can use. If suppose if you want some notes, then you can write it down there. And even the formula is important because naive bias is completely based on the mathematical structure, the way we have seen in the previously as well. But the naive bias classification algorithm is completely based on the Bayes theorem. Okay, so Bayes theorem is let me write sir notes and all. You can. So I am not changing this screen here. So you can, if suppose if you want to write down some notes, you can write it down. Okay, even formula is true. Formula has means formula is important here, right? And let's go for the some explanation about that. Actually, naive Bayes algorithm is based on the Bayes theorem. So Bayes theorem, why Bayes theorem is important? So Bayes theorem is completely supports supports for the conditional probability, right? Or probability, we know that probability, but what is the conditional probability? So conditional probability is nothing but suppose some thing is some process, some activity is going to occur. No, that is depends on the other activity. So something is going to happen. No, that is depends on the others. So it's kind of process. So if suppose this a activities happen, no, on the basis of A activity, some other activities happen. So this is condition. Okay. Rahul sir, Danny sir, I informed to my team. I think they are working on it. So they will open. Don't worry. Okay. So is it visible? Okay. So what is the probability? So major discussion about this today. Today's session is most important. So just concentrate on this. So naive Bayes classifier. And the second thing that we have to discuss about formula. Okay. See, so mainly naive Bayes classifier is mainly used for the text classification and means multi-classification concept. If suppose where there is a multi-classification concept, there we can dedicatedly we use the naive Bayes. But Today I have taken one example on binary classification. We can use the binary as well, not an issue. Binary classification as well as multi-classification. So you can implement on multi-classification or binary classification, it doesn't matter. Second thing, it is a completely based on conditional probability. Third, this is mainly used for the text classification concept. So text classification concept is nothing but whenever you go for the NLP concept, you will get to know about the natural language processing. But now we can concentrate on this concept. Okay. See the formula as well in front of you. That formula is there. So P of H, E, and P of EH. Actually, these are the things that I'm going to explain you coming slides as well. So let's go for this. Okay. So what is the naive bias? So naive is nothing but naive means because of assumption occurs in certain feature. Means the way I said that bias theorem is it's kind of condition. So it depends upon the some kind of condition. If something occurs is happening, then that is depends on the previous occurrence. So it's kind of okay. Depends on the principle of bias theorem. So bias theorem, it's based on the conditional probability. The previously I said. Okay. Now the major thing that we have to discuss. Okay, so see the naive Bayes algorithm means naive Bayes formula is there. Okay, the first thing that is, if suppose if I'm going to calculate some probability, okay, so probability of A based on given B. So how we can pronounce and how we can say means how we can pronounce about that formula, right? So probability of A given B, the first one, probability of A given B, second probability of B given A, then probability of A divided by probability of B, right? Bayes theorem, it's a rule actually. It's completely based on the conditional probability. So conditional probability means it's kind of, if suppose something is going to happen or some activity is going to be happening, that is depends on the other, means it's kind of dependency conditions. If suppose the way we have defined no if else condition kind of things, like example, suppose certain example, wait, I will show you, I will give you. You know the threshold, the way we have discussion we have done the threshold or a certain period of time. If suppose the point 0.5, the way we have defined the logistic regression, no, so value should be in 0.5 greater than 0.5, then this condition will occur. It's kind of that conditional probability. So it depends upon each and everything. If suppose if your ticket booking system is there, so ticket booking system is suppose the 60 books are covered, then this will occur. Means this condition will occur. So it's completely based on the conditional probability, certain period of that. But it depends on the multi-classification concept. That's what. Okay. So means each and every point that has a different behavior. The probability of A B given B. See the probability of A given B. So what is this? The posterior probability. So this is nothing but probability of hypothesis A on observed event B. So we are going to calculate suppose probability of A that B already given, means whatever you are going to calculate, no, that already given. See, means you have an data, on the basis of data you are going to predict. So that whatever the data you have, that you have to first check out. If suppose these kind of observations are already given, on the basis of that observation you are going to predict something. Okay, but it's kind of previous things, means the without any teaching and training to the model, you cannot do anything. Similar kind of funda, similar kind of process that we have here. But the point to be discussed here, each and everything is based on the conditions, right? So every observation, suppose the way I said that multi-classification concepts are there, I have taken one example in this slide as well. So I'll show you that example in this next slide. But first, we will explain this one. Probability of A given B, probability of B given A. Okay, the likelihood probability means probability of the evidence given that the probability of hypothesis is true. Okay, third one, prior probability, that is probability of hypothesis before observing the evidence. And then marginal probability means the last one. This is P of B. This is a probability of evidence. So evidence means what? Already evidence are given to the in the particular form of data, right? So condition we have to before prediction. Yes, correct. Actually, this formula is your conditional probability. Means this formula gives you that kind of process. That's why that's why they mentioned first formula, and then you can pass that whatever the suppose there is in three types. Wait, I will show you one example. I will go to the example directly. Advantage, disadvantage, actually I will discuss later. First I will give you first overview of this example. Means I never taken this example on the coding purpose, but in the slide I have taken a simple example in front of. Okay, so naive Bayes algorithm example. See this kind of data here we have, and fruits are there, yellow, sweet, long. Okay, and fruits name orange, banana, and other suppose. And probability of data used for the prediction. Yeah, it's kind of evidence already given. Yeah. So see this example, sir. Actually, if you see this example, you will get to know that. Right. There is a fruit data set, and fruits are yellow, sweet, and long. So three categories are there. Here, fruits are also mentioned: the orange, banana, and other. And these are the values. Means how much orange is yellow, the 350. How much sweet is the value, means numerical value we have assigned 450. Orange is long, no, 0. So total of orange, that is in total 650. Banana is yellow, this is sweet, and long 350. So total is in 400. Others means any other fruit is there, and that is yellow, yes, 50. Sweet, yes, 100. And long, 50. So total is in 150. So even we are going to do a total of this values. So yellow is, those are in the values that assigned. These are the total 800. Sweetness, that is 850, and long 400. Even we have made up here total of this subtotals, and here also subtotals of total. So 1200 is there total. So this is a data we got it here. Okay, so this is example purpose I have taken. Okay, so what is the problem statement here we have? We are going to find out the fruit here. We are going to find out the fruit. So which fruit means already they have given. We have to find out the fruit that is yellow, sweet, and long. Okay, we are going to find a fruit kind of yellow, sweet, and long. So we have to ask to the naive Bayes algorithm, please learn this data set and tell me who is a which is the fruit that is yellow is there, sweet, and long. Okay, so he will take that problem statement and go for the everyone, checking for the every aspects of that. So conditional probability checks for the each and every point. So naive Bayes is not like a, he will go for the all over the data set. Means it's not like a other algorithms. This is completely based on conditional. Means each and every. So he will take the observation points of yellowish, sweetness, and long. So he will check for the each and every data points, means fruits, because categories are there three. So we are going to find out that this is completely based on the orange, banana, and others. So on the basis of this yellow, sweet, and long, this is might be answer is in your banana. But if suppose if I'm checking with the values, then definitely we should get the answer of this one, means banana. Not while watching this one, banana is answer. But if suppose we are going to calculate the yellow, sweet, and long, then definitely we can get it banana. But what is the, so that's might have been used for the small data set. If plenty of data, it will not be accurate. Actually, what happens, it's not like that. I have taken the small data set for understanding purposes. If suppose there is a big data set, but there is an categories, no. There is not an, suppose uh, credit card fraud detection, if you have taken and two categories are there, it's not meaning of bias theorem we can use for the multi-classification. You can use the binary classification too as. But the point to be discussed here, this is more impactful on multi-classification. That's why I'm taking example of multi-classification and might have been used to small data set. No, it's not like that. Means it's not necessary to go for the KN is in small data set we can use. So how much data is there? How much data we have? That much accuracy will come into the naive. See what I have done. Do you know everyone the formula that we have mentioned? This formula. See this formula. Probability of A given B is equals to probability of B given A, probability of A and probability of B. Okay. So even the names also we have probability. So each and every point. Okay. See the screen here now once again. So given data set, we have to find, see what I'm saying, given data set, we have to find which fruit is there, because the question is in that should be yellow, sweet and long. How total is coming is just an example or some theorem is applied. Yes, you will get to know. Actually, total is coming on the basis of 350 plus 400 plus 50. So this is an 800. The observations are dummy observations. Don't worry. But total calculation is in same. Means that is accurate. 350 plus 400 plus 50, 800, 850. This is 400 and this is total 650, 400 to 150. Total is 1200. Nishan, you got the point. We are applying on that. No problem. See. So that observations means this problem statement, yellow, sweet, and long, we are going to ask to the everyone. No, we should ask for the orange, then banana, then other. Totals are not correct. Right side totals. Three fifty, 450. Okay. Yes. It's a union sum. Yeah, it's a union sum, but wait. Yeah, 800, it's correct. This is correct actually. And this might be gone wrong here. Is it? No. That is directly we have taken. Yeah. Total orange count. Don't worry. Actually, this is directly taken observations, assumptions. And sweet is in 450. Yes. So I'm get confused about this one. So this is total that we have. This is the assumptions that we have taken. So don't worry about it. No. You are making the addition, adding the both horizontal and vertical. That's why you are getting problem. Yeah. So actually this is wrong. No, means total. If I'm taking the total, then it's totally assumptions. Don't do. Okay. So we'll pass the values. Means just assumption. Do the assumptions. We have the this data. Okay. The last column may be total number of sports. Yeah. Okay. So check out one thing. We are asking to the model, no? And check out one thing here. The formula there we have, that is yellow orange, yellow banana, yellow others. Okay. So you are going to do with each and every one. Yellow orange, sweet orange, long orange. Now got the point? Are you getting something? You are going to do with the yellow orange, okay, not an issue. Yellow banana, yellow others, but side by side you have to do with sweet orange, long orange, yellow banana, sweet banana, and long banana. Now got the point what I'm going to tell you. You are doing with the yellow, you are doing with the sweet, you are doing with the long as well. So you can pass the example. I have added here one example with the orange. Yellow orange is equals to probability of 350. See, example I have taken. Yellow orange is equals to probability of 350 here divided by 800. So what is the formula? Orange divided by yellow. Okay. Then into probability of what? Yellow. Probability of yellow. Where is it? This one. So that is an 800 divided by total. This 1200. Okay. Divided by this total is not the sum of the 350 and 450. 0. It means that total and yes, yes, correct. Yeah. Okay. Now, actually, we if suppose we are asking to the data set, no model, so he should give us a fruit. Which fruit is there? So, what is the problem statement we have? What is the problem statement we have? Yellow, sweet, and long. We are going to find out, no. So, we have to pass that observation point into the formula. So, first formula is that yellow with orange. So, you have to ask with the banana. You have to ask with the others as well, no. So orange and yellow, orange and sweet, orange and long. So that you can pass the formula into the formula, right? So see here, yellow divided by orange is equals to 350, 800, 50, 800 divided by 12, and the probability of 650 is this one divided by 1200 means probability of yellow. So probability of yellow is this one. So we are taking the total orange and divided by 1200. So the value, the way we have assigned the value, so you have to ask, you have to add the value with the banana, value with the others. So not only you have to calculate the value with the yellow, you should calculate the value with the sweet and long as well. Are you getting a point, everyone? The bananas data and others too. So I have never done each and every one. Just I am giving you the idea behind this one. Okay. So long here definitely, and long is near there, orange is not long, so we got it here 0. But you have to ask with the everyone. It will go undefined. Yes, definitely. If you pass your data orange into the with the long, no, definitely you will get a 0 point. So I will show you the exact answer. Now the major point is to be discussed, you are going to the each and every point, not an issue. If suppose once we go through the point, the final value you will get kind of this one, yellow orange is equals to 0, because 0 is there, no? And if suppose if you apply with the formula, then definitely you will get an 0. Then yellow banana and yellow others. So this is observation. This observation is for yellow. So you have to calculate with another. Can you tell me? This is yellowish, no only. These yellows observations. So you have to calculate with the sweet. You have to calculate with the long. Either it will be the shape and size or color. Actually, data points we have taken yellow, sweet, and long on the basis. Means shape, size, or color. Color is there, but sweet and long, that is based on that. Not a logic, it seems. Y divided by 0 is equals to 0. Yellow divided by orange is equals to 0. Yeah, definitely you will get, actually see, if suppose yellow divided by orange is equals to 0, if you calculate this one, just calculate this one if you get this value. What will be the answer? Even I'm just little bit I have done. Length can't be 0. Can't be 0, Nishant, I know. But I have created that because we have to, at the end, we have to get the bananas answer, no? Are you getting? I have assigned. I'm giving you the process point. Example means how the values to be added into formula. At the end, your algorithm only he can do the work. He will not show you internal process. I'm just giving you example on the basis of means describing the formulas here. Because at the next time, if suppose you go for the examples, no new batch, what is exactly new batch, then you can get that each and every your data points, each and every category work with the everyone. Means orange is one, you're going to predict, no, orange, banana, or others. So then you are going to ask to the yellow and sweet and long. If suppose there, I'm taking another one example, then definitely there isn't some kind of instruction, but every category, every prediction category will go with the each and every observation points. And what is the behind the logic, that is an probability, this bias theorem, that formula, right? And then he's going to find out the some answer. So he's not giving a final value. This is giving us final value of yellow. Still we haven't gone through the which one, sweet, then long. Okay, so after that, after calculating the yellow, orange, sweet orange, and long orange, then you have to make a summation of these values. What I'm saying, after, wait, I will show you. After the orange yellow, orange sweet, orange long, you have to make a summation of values. And after summation, you will get highest number of count. If suppose there is an, now yellow is giving 0.65. So who is a big in three categories, means yellow orange, yellow banana, yellow others. The banana, yellow banana is big, no? So similar kind of that answer you will get into the sweetness. Similar kind of answer you will get in on the basis of long, and make a sum of 0.65, and sweet banana you will get some 0.2 something. So you have to make a summation and highest count will win here. So banana will win. So what's the independent and dependent in this? Dependent obviously orange, banana, and others. And independent is nothing but yellow, sweet, long, total kind of things. Yeah, sorry, yellow, sweet, and long only. Are you getting, Rahul? We are not passing this on the that algorithm. Just for the understanding purpose, I'm taking this example. Which independent data? Independent data, you can take a fruit. sorry, dependent variable prediction values, you can take a fruit, and independent values, you can take an yellow, sweet, and long. Hope. What are the things to attain? Means I'm not getting. Actually, behind, see, the questions on the basis of naive bias, you will get into the bias theorem, because uh, on the objective of this formula is you have to get highest probability value, right? So because you are going to find out the unique category, right? So highest, you are going to find out the unique category. So each and every category you will find, will go and apply on the observational point, means yellow observation point, sweet observation point, each and every independent values, and then he will give you the do you have another data set? Yeah, I have taken an example of other data set as well, but for the formula purpose I have taken this example, okay, for understanding purpose. But tell me, have you got this formula? How this formula works? Then how come yellow and orange is equals to 0? Can you pass these values into the formula so that we can get it easily? This looks the random forest, easy to predict. Not sure about accuracy. Actually, whenever the data we get, no, whenever formula we understand, no, it looks an easiest. The observation is in 350. Yeah, actually we can pass it into the formula. Can you calculate this one? 350 divided by 800, 800 divided by 1200, and then 650 divided by 1200. Is this used if we have more than one independent variables? Yeah, you can use a more than one independent variable. It doesn't matter that we can take it. This formula is conditional probability. No, bias theorem formula. This is bias theorem's algorithms for a similar kind of conditional probability. Okay, I have to check that conditional probability formulas too. I'll check one. I mean, the belongs to like conditional. Yeah, it's kind of conditional probability. Yeah. At the end, you are going to check. No, see, Nishan. At the end, the way we have the yellow and yellow banana, yellow sweetness, yellow long. Sorry, yellow banana, sweet banana, and long banana. Similar kind of that you can check for the orange. You can check for the others too. Then afterwards, definitely you will get in some kind of three answers. Means orange data you will get in three answers. Banana you will get in three answers. Others you will get in three answers. Is it correct? Yes or no? Tell me now. Means because algorithm is there, your formula is there, and you are going to apply these values on that for particular formula. Yeah, actually, whenever the explanation is there, it looks an easy. For understanding purpose, this example is easy, not an issue. Yes, Nisha. I will pass into that data set. Only only formula, only libraries that you have, you will get into the explanation point when we are going to implement the algorithmic process. Only Gaussian algorithm is there, right? The name of naive Bayes algorithm in machine learning, that is an Gaussian naive Bayes. So that's it. Only that thing you will see on that coding part. But the point is that, what is the major structure? So what is the behind structure about this probability, right? Y is not an zero. Y yellow divided by orange is not zero. Is it calculation you have done, sir? I have to check once why this is not incoming 0. Wait. Might be you are correct. If suppose I will check, just give me a minute. Is there anyone that you have checked this process? No, 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 no. Actually, what we have, Dennis sir, I got your point. If you calculate, if you calculate yellow orange, sweet orange, and long orange, then you will get an answer of 0. Now, what the point? This is not an yellow orange point. This is an all yellow, sweet, and long. Actually, I have mentioned here yellow, but at the end, after the calculation of yellow orange, sweet orange, and long orange, you will get an 0. Check out once this is correct or not, because might be this is a little bit. And no need to do a summation. You have to do a multiplication of this three. Means whatever the output you will get in, that is a multiplication. By mistakenly I saved that summation. Whatever the output will come, no, orange, yellow, orange, sweet, orange, long. You have to do a answers multiplication. Whatever the answer will come, no, 0 or 0.65 and 0.72, 0.72. Have you tried this example? You got the point? Please let me know into the chat. Yeah, this is point yellow orange only, no, Dennis? Yeah, then there is an yellow orange, then there is an yellow orange sweet, orange long. Then after the value, whatever the value will come, no, you have to do a multiplication of these values, and then you will get an 0 might be. I have never mentioned here total example here. And banana also same with the yellow sweet long, and others also yellow sweet long, and then definitely you will get some kind of answer this one. So maximum probability value is in 0.65. So here probability of banana 0.65 will win, and your final answer will be there banana. Because what is the question that we have asked? Which fruit is there that is an yellow? Which fruit is there that is an yellow, sweet, and long? So that comes under the banana. So as ethically that banana is in long and sweet and yellow. If suppose if I mention there orange some values with the long, no, definitely might be gets the changes in between the output. So that I have mentioned here 0. You got the answer here. You got the example. Yes or no? Everyone, I'm just asking to you all. I think we can continue the class and maybe the doubts. Yes, I'm just going to give you the example of it. No one asking you formula. They will ask you, explain the new bias. If suppose any of the project or any of the example, if you explain, then definitely they will ask you what is the new bias, what is the why we say the bias theorem and like that. So you have to tell them that is completely based on the conditional probability and all. Okay. So there I have taken one example here, and I have even updated on just I have updated on this Google Colab. Okay. So see, I have mentioned here definition. And here I have taken the social network ads, that is an binary classification example. Okay. First, we will go for the binary classification example, and then I'll give you a multi-classification example to run this. I will give you for the assignment purpose multi-classification. See, this is a data set, age and estimated salary and purchase. So the way I said that you can use on multi-classification as well as the binary classification. So I'm using here binary classification example, and that is an here I have mentioned SQL and dot model selection, import train test split, not an issue. This is, you know what, actually, this is an example of already means formal execution, because it looks like now normal, because previously we have done this one. So you can pass into the cross validation technique too. X train, X test, Y train, Y test, and then I have taken the 75% of data for the training purpose. Okay. Yeah. So only this thing only we will get into the new base. Means the way we have seen in the logistic regression, no, only like assigning the libraries and you will get an answer. So with this one, how can you get this? Please copy the link of dataset. Actually, link dataset I have shared with already. You have, no? I have updated on the portal too. This dataset you will not get through the Kaggle, but I have uploaded on the portal. But I will check. No, Jupyter is not working. Actually, what happens? I'm working on the computer vision project, and suddenly the whole process is crashed while we in the last session too. Anaconda, Anaconda is important for me because I'm working on the Keras and TensorFlow in the convolutional neural network. So that's why I'm getting problem. So I'm working on the collab continuously with the different laptop. Actually, my after uninstalling Anaconda and other things, my laptop isn't getting faster than ever. That's why I'm just staying with this Google Colab. Can I ask one question to you all? Is it possible to use this Gaussian means this neo-Bayes model to the cross-validation technique? Is it possible? I'm asking to you all. Is it possible to get this neo-Bayes? See this sklearn dot neo-Bayes and import Gaussian and we mean Gaussian neo-Bayes. This is a class that comes from the neo-Bayes technique. Okay, and this is a classifier means object, and that object we are going to teach what X-train and Y-train. So what do you think? Can we pass this data to the cross-validation technique? Yes or no? So this is a major question that I would like to ask you all. Split data into the k numbers, yes, and we have to pass this naive bias into the looping structure. Means looping means cross-validation technique. Because this question is important, that's why. If suppose no one will tell you how to improve the accuracy, because improving the accuracy you have a lot of ways. Means you have to change the model structure and all. So in that, one of the technique that you can use the cross-validation technique. So maybe in the previous yesterday class and last Sunday also we have seen the voting classifiers as well as the which one averaging as well, right? Even bagging technique and random forest technique also we have seen. So these are the techniques that can be used for improving the model accuracy as well as the trust on the model. Means always the peoples they ask how much size test size we can set, how which algorithm we can use. So why not you just work on the ensemble technique to improve your model? And neo bias is one of the kind of means it's kind of logistic regression can as well. So maybe if suppose if you're working with the neo bias, just understand the logic behind that, because logic is in completely based on the formula, right? And if suppose you know the formula, then everything is correct, not an issue. Because whatever the work will happen, no, that is come from the class. I mean this class that which class that we have assigned here, neo bias, right? And that's why I'm just telling you, you can go with the first formula working, means how the formula works and whole structure will work. And if suppose if you want to work on, see what I'm telling to you, if you want to work on the basis of cross validation tech, on the basis of cross validation. If because if you don't know the imbalancing and cross validation technique, because these are the techniques can be improve the model accuracy as well as means if you want to see the consistency, then also this cross validation techniques and imbalancing technique will be useful to you, right? So I will give you for the example purpose, I will give you one data set for the assignment purpose on the basis of naive Bayes, because today I will give you introduction about the k-means clustering as well, right? So this will side by side we can do the example of this. Do you know the wine quality prediction on the Kaggle? I think previously I have shared the data set. Is it? Have you? I will share the link too. You can go for the assignment on this one. Okay. You have to predict see, this is quality. And if you want to predict a quality, means output is a based output variable is based on the scenario. Means this is an quality, no? That's why. So 0 to 10, you will get an output here. And check out where is that score bar. Hmm. Or this is also correct because this is looks like an continuous data. You can pass into the first type. Not in this data set actually. Wait, I will upload on. Yeah, this one is also. Do you know the iris data set? Anyone? This is in flowers. Iris flower is there, and you can iris. You can take this data set as. See, but one thing you have to do, you have to do a label encoding on this basis. Is it possible from you to do a label encoding and apply for the prediction in naive Bayes? Yes. Do you know anyone that label encoding that we have done? Yeah, you have. There is an. This is an flowers data set. We can apply one hot encoding. One hot encoding is also good because wait, I will show you. Dot. I will check the. I will show you the categories. Three categories are there. Sentosa, Virginica, and another one is what we are trying to do now. No, I'm giving you one exam, one assignment to you for multi-classification. You can work on it, right, Rahul? So this will helpful to you for more understanding on new Bayes, so that I can go for the k-means clustering. See, there we have the predictions. Means we are going to predict Iris Sentosa, Iris versicolor, and Iris virginica. Means iris flowers are there, and these are the sepals. Means it's kind of sepal length, sepal width, petal length, petal width. It's kind of flowers, and flowers has some features. So features that species of this one. These species we have the three types. That is Sentosa, versicolor, and virginica. So you can convert them with the one hot or label encoding, it doesn't matter. But prediction purpose, you can pass the y column is this one and observation column is this one. Is it possible from you? The independent variables are this one, and you can take a dependent variable of this, means spaces. Do you have iris data set, or I can share with you? Can I share with you? You got that? Okay. Wait. I will just close down this content and open the k-means clustering. sklearn dot pre-processing import label encoder. You can use that one also, sir. Label encoding or one hot encoding. You can use label or one hot. You even we have discussed upon the mapping as well with the one hot encoding. Mapping means if suppose versicolor, you can pass this on for loop and conditional if else condition. You can put the if else condition, pass, create one column on the basis of. This is also easiest work. Not only you can do the label or one hot, you can do with the pass the column into the for loop and also add the if else condition and get and create new uh, what list, and that list you can pass as a column into the last position of the table. So this is the one of the easiest work as well. Is it correct or not? Because three categories are there, no, that's why it will be easy to implement with the basic coding. We have done that one. Yes or no? How about if I run into k-fold or random forest first, then use the new base? Uh, would that make any difference when the prediction? Actually, see, random forest, in the random forest, there is a bagging technique that I have shared the code. In that, you can use the naive Bayes algorithm. Are you getting, sir? Rahul? Yeah. And you can do one thing there. K-fold is compulsory, means it's not a meaning of K, we can use K-fold or not. See, it's kind of, if you used to with the K-fold technique, no, means cross validation technique, you can pass any algorithm in between that, not an issue. But random forest, or if you are taking bagging technique, random forest uses the decision tree. Is it correct? And bagging technique use the decision tree as well as the other algorithms as well. Because if you pass the base estimator is equals to logistic regression or new base, is it possible from the bagging? No, it's correct or not? How about accuracy of new base? It's same that you can do with the regular algorithms. Means not in the same, means if you are using the naive bias, then definitely you will get a different, some differentiation between that. There will be the difference in prediction, obviously if you pass into, why I said this, means confirmly why I said the difference, because see, if you are using naive bias with the bagging technique and passing the new data sets with the every loop, then just let me know, that is an highest possibility is that you will get a different outputs, different prediction values. Definitely, because in the regular manner, you are applying only 180% or 75% data to the predictions in the new base. So definitely there is also change. You will get in changes. Why? Because every time, 5 times, if you are passing k-fold size, then he will change the data set observation values. Also, each loop changes. No, in the cross validation. Wait, I will show you one thing. Nearby is quick prediction. Audio industry uses this kind of structure running into the back than Nearby's. Yeah, actually, if suppose you are one structure, it's not necessary that every company goes with the different algorithms. Sometimes, if suppose some of the data set, if suppose sugar mills data set is there, or any credit card fraud detection, if they want to choose, then if your output is coming on the basis of logistic regression and you are trustful on that, means logistic behavior, you got that, logistic works this way and my data is enough to predict this one, because you are applying your previous observations on that and getting output accuracy, is correct or not? So any of the company, they are not using like a all six algorithms. They are working on the only 1 to 2 algorithms. Why? Because they already train and getting the observation points and checking the outputs as well. But I'll show you one thing. This is I shared the file of random forest part 3. I think you guys have seen, and yesterday also I have updated on that. See, so random forest classifier, logistic, and k-nearest. Is it possible that you can pass here the naive bias as well? Is it yes, correct or not? Yeah. So you will get in 4 algorithms. It doesn't matter that you can take on 1 or 4 algorithms. You can pass any number of algorithms. And if suppose if I'm taking 4 algorithms with the naive bias, and you can pass these algorithm values, means objects, into the max voting. check out the voting classifiers are there, RM, L1 and KM, and you will get into max voting as well. But this is with the cross validation. See what I'm saying, with the cross validation technique. If you go with another one technique, I'm going to show you. I'm not in this part. I'll show you. I'll show you another one. See, here I have created RM, L1 and KN objects and trained 2 here data. Then comes into the prediction part. Okay. And after prediction, I have made one thing. That same thing that I have done, same thing, but here I never pass this voting classifier into the cross validation technique. Now, what is the difference in the previous part 3 and part 1? Are you getting my words here? Here in the voting classifier, that algorithms that I have mentioned, they are taking only one data set, not an different 5 times data set. Only one data set, that is an X test and X train and Y train. But in the previous point, every time they are getting new data set, means this one, that is an X train Y train. Right? Is it correct? This is the difference. Then why not you pass your naive Bayes 2 in between that? Just see one more thing I'm going to show you here. This is bagging classifier. Okay, bagging classifier is major point in the whole ensemble technique. See, in the bagging classifier, base estimator I am passing L1. So why not you pass not only L1 is nothing but logistic regression that I have created the object. Okay, you can create the naive Bayes object and pass into the base estimator is equals to naive Bayes object. And n estimators are there, nothing but 5 subsets. And that's it. Your bagging also will go with the outputs. Is it possible? Are you getting my point? Actually, see, the question I got. See, if suppose you know the points, you know the X train, Y train, the concept, it looks an easiest work. But your experience is important in what type we have to use which technique. Means if you have a multi-classification data set and then which algorithm, which technique we have to use. Many of the people, they are thinking about machine learning is an easiest work that we can pass the data and get it output, not an easy. So this is not a meaning of that one. How the data accuracy, how the prediction accuracy we can get. That is important. You can use the logistic regression or you can use the KNN. But at the end, your accuracy, whatever the prediction will come, no, that prediction is correct or not, right? There we have the different types to apply on them. But if you know the different types to apply, your trust on the prediction increased more and more. Are you getting my point, everyone? Yes or no? Technique should important. Yeah, exactly. Okay. So hope so. Till now, the whatever the things that you have learned, hope you got till now. Means from the starting of the logistic regression to till now, I'm saying. And because we have learned so many things that we entered into the deeper and getting outputs as well. The cross validation technique and ensemble techniques, that all these process, what are the points are important that I'm going to mention into here. That is first one, see, random forest, max voting, averaging, and imbalancing techniques and cross validation. These are the major points techniques. Algorithms are important, not an issue, but these techniques helps you to improve your accuracy and improve your trust on the model prediction. Okay, so always do not miss to learn about cross validation technique and imbalancing technique. Imbalancing helps you to balance the data. Cross validation gives you the multi subset execution so that your accuracy will become a more stronger. You got till now? Yes or no? Yes, yes. I'll share with it. So I have created one 70 to 80 questions on it, on this whole machine learning, Python, and data science as well. 70, no, 100 plus questions I have created. Okay, so every part of the question in this one you have with the answers actually. So that I will share with you, not an issue. But I have to, at the end, actually today evening, I will update that one. This is for the every students that I'm taking the sessions, right? So see, basic interview questions I will tell you. What is bias theorem? First, second, on the basis of naive bias, you want the question or what? Whole machine learning. Then I will share with you the file. All right. Okay. So let's go for k-means clustering. Okay. Would you share the file with the example of naive bias? Yes, yes. Actually, examples as well as the PPT I will share with you. PPT might be you will get in some little bit confusion, but I will share with the file. Means that that IPYNB file. Yeah. Now we are going to discuss about the unsupervised clustering concept. So what is the unsupervised learning? Unsupervised, are you going through the that quickly now? Which one? Uh, Recap, implementation. Actually, that's why I'm just not an, I have never done the calculation of point, but that only library you have to apply. That's why that naive Bayes or any algorithm getting tougher to understand. Right. I will share that file. Today I will give you introductory part of k-means clustering, and the implementation will go for the tomorrow. Even I have opened this point in front of you. See. So what is the exactly k-means clustering? See what I'm saying. K-means clustering. Clustering is nothing but groups, collection. What is that? Collection. So you can take the example of clustering concept, that is, it's kind of, if suppose there is an unlabeled data is there. See, because in coming, yeah, unsupervised started. I'm just giving you introductory part today, only execution implementation, but I'm not explaining you a k-means clustering. I'm explaining you the unsupervised structure. Okay. I'll give you the some introduction part. See, what is the unsupervised? Unsupervised has an only k-means clustering. Okay, there is an you can deal with the how the clustering works. Unsupervised clustering is an unlabeled data set. It works on the unlabeled data set. So I will pass some examples here, means definitions here, so you can get it easily. Okay. If suppose there is an not unlabeled, labeled means what is the meaning of this one? What is the labeled means? What is the meaning of unlabeled means? There is, you cannot have any kind of dependent variable. See what I'm saying? In unsupervised learning, you will not get any kind of prediction values. Unlabeled, on the basis of your observation, you have to find out which category he is belongs to. Are you getting point? Unsupervised means unlabeled data set. You cannot, you will not get in. There is in the previously we have seen one data set that suppose this one. So on the observation points are there and outcome is there. So you will get in which outcome will be there, which outcome means this is a true or false, or it's kind of classification. But in the unsupervised, you will not get this kind of classification or regression. On the basis of your observation values, you have to find out which categories belongs to that. If suppose, if I show you some example on this one, suppose small customers are there, right? And only observation points you will get. So you have to make a categories on the basis of small customers, which area and which kind of means you will not get kind of things, prediction values. What you have to predict. If suppose if I make the groups of these small customers, see what I'm saying. If you want to make a group of small customers, you cannot say that this spending score will be the dependent variable. Annual income would be a dependent variable. You cannot say like that. Only you can just imagine that how can I make the groups of all this means major customers kind of suppose if I want to go for the annual income is this one. If you want to make a 5 cluster of this small customers, 5 clusters means 5 groups. If you make a 3 clusters, then he will create a 3 clusters on it. So 3 clusters means 3 categories he is going to create. It depends upon the observational point. So this is a little bit tricky to understand. I will show you one example. Wait. So 3 categories will have the average. I mean wrong. No, actually, what will be there? You can check through the average as well as it depends upon the observation points as well. So average means if suppose there we have the see this is a data set. Is it visible this screen? Right? See This is a collection of data, suppose, and you want to create a categories, clusters. Cluster is nothing but groups. See what I'm saying? Cluster is nothing but groups. So what you are going to do, you have to make a group of similar data points, similar type of peoples you can say. So there we have the red type of people, yellow type of people, and blue type of people, suppose, right? And you are making that groups. So how can I make? Because there is a no one says that is I'm a red, I'm a yellow, I'm a blue. No one tells you that he's a green, he's an means yellow, or he's in red. On the basis of features, you are making them three types. If you try to make a four, then four also implemented. Are you getting my point? What I'm trying to say? Small data for from the each cluster goes into the prediction. Small data from each clusters goes into no, actually not like that. Actually, say if you have a collection of data and you don't have a prediction column, is it correct? This thing is correct, no? If you have a data, the 4 to 5 columns are there, and you don't have any prediction column, but you are going to create a clusters of similar data points. So it depends upon you how much clusters you want to create. It suppose if you say I want to create a 10 clusters, then he will create a 10 clusters of similar data points. If suppose cluster 1 is he has created, then he will find out the similar type of clusters only. If suppose the collection of peoples are thousands of peoples are there, and suppose you will say create a two clusters of random two clusters of these peoples, means two clusters means he will find out the similar peoples like and means similar kind of faces, who those are similar kind of faces might be getting clarities in same. He will create a clusters only twos. If you say three clusters you have to create, he will create a three. If you say that you have to create a five clusters, he will create a five, but similar data observations. Wait, I will create one example in front of you, because this is the only thing that might be getting confusing for the peoples. So what those clusters will do? Only predictions. You are creating a prediction column. Are you getting, everyone? In the supervised, you are not getting any kind of prediction column. But in unsupervised, it's kind of creating a prediction column. On the basis of observations. Are you getting something? In the supervised, you have a prediction column. No, why prediction column? Credit card fraud detection, yes or no? Diabetes, heart disease, yes or no? There we have seen iris data set, that is the petal length means that type is nothing but that versicolor, virginica, or sentosa. You have the prediction point, but in the unsupervised, you don't have any kind of prediction column. You have to create your prediction column with the unsupervised. So how can you judge that how many clusters you want to create, how many types you want to create? So that purpose you are creating K means clustering. K is nothing but your how many clusters you want to create. K is count. The way we have seen K nearest neighbor. So how many nearest neighbor you want? K nearest neighbor you want. If suppose if I have passed the K is equal to 5, he will find out the 5 nearest nearest neighbors. The similar kind of that In the k-means clustering, if I'm working with this unsupervised learning and unsupervised has an k-means clustering type observation, k-means clustering algorithm. In the k-means clustering, if you set up k is equals to 5, then he will create a 5 clusters. If you say k is equals to 3, then he will create a 3 clusters. Clusters has a load of data. It will release little bit of data for the prediction, all the data clusters. Just clear clusters. That's it. Just clusters. No big deal here. Are you getting everyone what I'm trying to say? You are creating your Y prediction column. See, once again, I'm going to give you one example. You guys are thinking about, if suppose clusters are created, then how he knows that same observations are there? See, here also distance concepts are there. What I'm saying? Distance concepts are there. Suppose collection of peoples are there. Collection, thousands of peoples are there. Okay. And just imagine you have to create three clusters. What I'm saying? Three clusters you have to create. Suppose the red, green, and blue. Suppose, but you don't know that red, green, blue is there. But your unsupervised learning, K-means clustering, will do one thing. He will find out the similar type of observation from the people, similar type of peoples. Those are in the similar. So he will check first how many similar data points are there. So suppose he will find out some 50 peoples, 70 peoples, 30 peoples. Means suppose total data points are there 150, and you know that you said to the algorithm you have to create a three clusters, and three clusters if you are creating, it's not necessary to clear, it's not necessary to come up with the three same size of clusters. Might be he will create a 20 of red, 80 of green, and 50 of blue. Might be chances, because if suppose your observation points, similar observations are low, then he will create a low kind of category, low kind of clusters, because you are setting up a cluster size is 3, means k size is equals to 3. And you will say that if suppose these are the peoples, and he find out the similar kind of observations, and he might be going for this, creating us this kind of structure, then how he knows that the red is present here also, that red is present here also? So we pass cluster before, and then there is a no default in this. Yeah, you are not getting any kind of default parameter, and not any kind of default argument. Means you can start from this position to find out. Are you getting? Means you are not getting here. See, first thing, he will take one observation. Means he will take on three observations, unique observations. Is it correct? Because if you are going to find out the two people's different, you are going to create a two different groups, then first you will go on the basis of size. If suppose you will take a longest one and shortest one person, and on the basis of you are going to sort out the peoples, no. So similar kind of funda you can do here. Clusters who will find out the peoples, no. Then he will check that I have to create three clusters. Then first I will take one of the any random values. And from that random values, he is going to find out who is the nearest one. Are you getting? Who is the nearest one? And then he will check for the every observation point. If suppose he is getting the similar kind of data points, means looking like a Abhay, looking like a Abhay. He's looking like a Abhay, no. He's looking like a Abhay, no. So after that, he's getting the all the observations, similar data observations. Then he will create a center point of them. Means in the room where there is a person kind of away, he will create a center point. That center point is nothing. Center. How can you calculate the center with the mean? With the mean median mode is there to calculate the center point. Mode is there, median is there, and he will calculate the center point, and that center point is nothing but centroid. So every cluster will create a center point of each for the each cluster his own, and each cluster has a center point, and he will create a clustering in similar data points, similar data points, similar data points. There we have the different observations and creating the center points. So every cluster has his name: cluster 1, cluster 2, cluster 3. You know what? See, now I'm going to show you one example. I'm not explaining you code, but I will explaining you the at the end of the point what you will get. In that also you will get the differentiation. You cannot say that this data isn't same. He will find out the difference in that. Are you getting? How much k of size you are passing? No, if suppose you say the 3k size, then he will find out the 3. I think, see here, k size deciding purpose, we have the example here, elbow method, to finding out how much k size you can take. See here, on the basis of k size, you will get this kind of structure. So elbow method will helps you to finding the k. I will tell you tomorrow, because the where the curve is bending, that point first bend you will get in k size. So 4 and 6 in between that, the k size will be there. Are you getting, Priya ma'am? The first bend, okay, means he will give you some another observation. The second bend also there, you will get an 3. You can pass 3 or 5 for the k size. You have to pass this formula, means this clustering point, that you have to create this one list, okay, and you can pass the data. K means is equals to k means clustering I, init is equals to k means. This is a method for initializing the k means clustering, and then random state, and then train that x data. See, I have trained the x data. I'm not passing here x train and y train. X data, because you have only observation values, no, and passing the observation values, and that's it. You will get an whole execution of this one, and first bend of first turn of this one, curve of this one, you will get a point k size, and you can pass the n cluster. It's not necessary to do this one. If suppose if you are able to pass and understand the k means clustering, then you can take yourself that what kind of value k is equals to 5 I can pass, or 7, it depends on you. Then k means is equals to k means, and n cluster is equals to 5, and initialize the method of k means. That's it. You can train them with the k means dot fit x data, because x data we have taken, and then you can print this one. See, the way we have taken this point, no, check the prediction point that we got, that is in yk means. Yk means is getting 5 clusters, 5 types. So each and every data points, see, this each every data points, 200 data points are getting into this one. 200 data points are getting into this one, right? And each and every one will get this. First observation will come third category, means third cluster. Second will come into the zero cluster, zeroth number cluster, third cluster, and similar kind of that. Each and everyone will give you the output. So let's see how much categories are there. 0, second one will be there, third is also there, fourth is also there, and Fourth means k. How much k size is there? N cluster is in 5. Then definitely the whole data is divided into the 5 clusters. Are you getting my point here? Here, and just let me know, is it possible to create a Y column here? Because this is in your category you have chosen. No? You have created. Are you getting my point, everyone? You can create a last column for this one. Means you can pass this data into the last column. Means you are creating labeled data set. Unsupervised nothing but unlabeled data set. No. And with this one you are creating you are creating clustering point, and then you can go for the prediction purpose, and after this one you can use the unsupervised algorithm as well, because you have created a prediction point. Is it correct? Are you getting some logic behind this one? I will give you the examples on tomorrow, because k-means clustering example also, and tomorrow only I will give you some quick recap about algorithms and all, and then will implement introductory part also tomorrow. I will explain you of in. Okay. So today we have covered supervised learning, introduction part of unsupervised, and tomorrow I will cover up this point. Till then, you can work on that data set, iris data set point. Is it possible from you to work on the iris data set? Yes or no? You can pass into the new Bayes algorithm and give me the output as well. Means tell me tomorrow. You can tell me the what is the example, what is the difference you got that on the basis of that. So tomorrow we'll go for that, and clustering. I will give you means all process tomorrow. Okay. Thank you so much for joining today's session, and see you on tomorrow's session. Thank you so much. Thank you. I mean, suppose if you don't have any kind of label, means you don't know how to make a prediction point. If suppose there isn't kind of data, no, without any prediction data, and if you want to create a uh, group of peoples, similar data points of group of peoples, that time you can use the k-means, because if you know the peoples, if you know the categories, if you know the prediction point, then no need to apply k-means. K-means only works on the unlabeled data set. There is a no label, any kind of labels. So you can use the k-means and create a group of peoples, similar data points. Yes. K is neighbors. K neighbors is nothing but finding the nearest data points. Neighbors are different because already you know the labels, and you are telling that you have to find out Abhay or Rahul, right? And you are finding who is the nearest to Abhay and who is the nearest to Rahul. Suppose you are asking, you are passing one person in between Rahul and Abhay, and you have to find out he is a Rahul or Abhay, right? And then you will find out the nearest person out there. That's it. Because you nearest neighbor KNN or K means are different. KNN is and based on the label data set. K means on the basis of unlabeled data set. Hope you got this point. Yeah. Thank you. Thank you all.